last video. Let's solve quadratic type equations. Now let's talk about what we mean by that first. Now if we look at a quadratic equation, usually it's something like x squared plus 5x minus 8. Something like that. You may have noticed that our middle term, our first term is always double the middle term. So this one is double this one. And you'll notice that the same is true for both example 6 and example 7. This is double that. X to the 6 is doubled x cubed. X to the 1/2 is doubled of x to the 1/4. So that's what we mean by quadratic type equations. They fit this doubling pattern, where it's doubled and then nothing on the end. So when we have this quadratic type pattern, this doubling pattern happening, that means we can do a process called U substitution. Now, this process is only important to make this whole equation look nicer. That is the only point of U substitution. It is just there to make everything look prettier while we factor, so then we can factor it better in our head. So let me try to explain what I mean by that. What I'm going to do here is I'm going to say U equals x cubed and U squared equals x to the 6. So do you still see my doubling happening there? I still have that doubling pattern. But I'm going to change this to 5u squared plus 8u minus 4. So all I did was exchanged the x to the 6 for a u squared and an x cubed for a u. And I can do that because it's still the doubling pattern. We're still doubling from u to u squared and from x cubed to x to the 6th. It's still being doubled. And the only reason I changed those to u's was so that I could make this look prettier. You'll notice that this with the u's looks a lot nicer to factor than this. And that is the whole reason we do it. It's just to make it look prettier for the factoring part of the problem. So now I want to actually factor this. You may have noticed that this is going to be our harder method of factoring because I have a number in front. So I'm going to take first times last, gives me negative 20. And I want to multiply to negative 20 and add to 8. So it seems like that's going to be 10 and negative 2. That multiplies to negative 20 and adds to 8. So I'm going to exchange my middle term. Let me make sure I can make this look nice. For these two numbers. So plus 10u minus 2u. So 8u is the same thing as 10u minus 2u. I just exchanged it. So it's the same thing. I didn't actually change it. I'm just exchanging it out. And now I factor something out of there. They have a 5u in common. Factor something out of there. They have a negative 2 in common. And then both of those have a u plus 2 in common. So I take a u plus 2 out of that. I'm left with 5u. And when I take a u plus 2 out of that, I'm left with a negative 2. And now I'm all factored. Now, at this point, I'm actually going to go in and change my u's back to what I started with. Because remember, the only reason they were used in the first place was to make the factoring nicer. And now that we're all factored, we don't need them anymore. That was their whole purpose. So u was an x cubed here. So I'm going to change both of these u's back to an x cubed. Everything else in there stays exactly the same. U cubed plus 2, 5x cubed minus 2. So this is actually the factoring of this. So this one up here was factorable, even though it may not have looked like it in the beginning. That is the whole point of this middle u substitution part, is just to make it look prettier so the factoring is easier to do. Now that I have it all factored out, I can do my last step of always setting them individually. Equal to 0. So I get x equals the cube root of -2. And remember, we can cube root negatives, we just can't square root. Or I should say even root negatives. And then I go to solve the other one. So I get x is the cube root of 2/5. So those are my two answers. So let's try that again with another example. We've got this one right here in example 7. Notice once again that the doubling pattern is happening. So as long as we're doubling, I can do my u substitution. And we'll still see the doubling happening in our u substitution. We double here, we double there. So now I can say this is u squared minus x to the 4th is my u, minus 6 equals 0. And you'll notice once again, this u substitution just made the factoring a lot easier. It's easier to look at this and factor it than to look at this and factor it. That is the whole purpose of this u substitution, just to make it look prettier for factoring. This is our easier method of factoring because we don't have anything in front of the u squared. So I just need to multiply to -6 and add to -1. So it looks like that's going to be -3 and +2. Now that I am all factored, I can change the u's back because they served their purpose. They helped me factor it. That means they're done. So now I can change the u's back to an x to the 1/4. And now, same as last time, now that it's all factored, I have everything plugged back in. Set them both equal to 0. Just a little reminder for you that x to the 1/4 is the same thing as the 4th root of x. So I have the 4th root of x equals 3. And the 4th root of x equals -2. So I can do this to the 4th power to get rid of my 4th root, and I get x equals 3 to the 4th, which is 81. But you will notice a problem over here. I have an even root. Is an even root ever going to equal a negative? No, that's not going to happen. We can't put negative into our even root. So this one is not going to work. That means that is our only answer. So that is u substitution. You are officially done with lesson 2.1. Congratulations.